union types and how that affects the design recipe. So a union type, like we talked about before, is simply saying, hey, I'm one of these, or one of these, or one of these. And you might have 3 variants, or 7 variants, or maybe just 2 variants. Okay, so just a quick zoom through again of the design recipe steps. We've added steps 1, 2, 3. And so step 1, make a data definition. And in our example we worked through earlier about a lookup result, that's the first thing we did. A data definition is something or something or something. And those ors are what tipped us off that, hey, this is going to be a union type. The next thing we did is make examples of the data. When we worked through this example, I hadn't told you these were the steps of the 1, 2, and 3, but we did them anyway. And then we went ahead and decided that now we came back to it, but we said, every function that deals with a lookup result is going to have the same shape. We have a data definition that has 3 variants. We're going to have a con with 3 branches. Okay, so we went ahead and actually going to zoom down here. And step 3 would be make a template for any function handling this type. Okay, and our only template so far is a con with as many branches as there are variants to the data type. Now we can copy and paste that. Now we come along and say, hey, here's a particular function. So that's why I have that little per function line sitting there. Now write a particular function. Oh, okay, now I'm going to write test cases. And when I'm doing my test cases, I might use those examples of the data. I'm going to stub out my function, including a signature, a purpose statement, a header, and then the stub body. I can go ahead and copy and paste this here. So in fact, even in my template, I include a little thing that I can flesh out to be the signature. Purpose statement I can't really say much about in the template. I have to wait till I know what function I'm going to actually write. Okay. Yeah, so every particular function you have me write, I'll copy and paste this template as part of writing out that stub function. Then I'll go in step 7, complete that body expression, think about the logic that's required, and that's what we did last time. So let's work through one more example. We look at a couple of different union types. So the first one was this lookup result. We mentioned a stoplight color can be viewed as a union type. It's maybe an enumerated type in this particular case, but an enumerated type is a special case of a union type. Okay, so, and we sort of said, oh, a stoplight color would be one of these. That would be our data definition. Be examples of the data, pretty easy if it's an enumerated type. I can just list them all. And then go ahead and give a template. Again, the template is going to be a con with 5 branches, since there are 5 variants of a stoplight color. Okay, then we come along, hey, write me a function involving stoplight colors. And so we wrote the turn function. And so we did our test cases. We grabbed that template, and then we were able to fill it in. The template had ... but step 7, we were able to fill it in pretty easily. Okay, and then we had another function for stoplight colors. So penalty for running a light. And we repeated steps 4, 5, 7, 8. We don't repeat steps 1, 2, 3. We already know how we're representing stoplight colors, and we already have a template for it. So, okay. So I think that was all pretty straightforward. And I'm now going to go ahead with the more in-depth, actually typing along as we go, another example of union data. It feels a little different. So we'll talk about taxable income. So we're going to maybe be writing some tax software or something like that. How do we represent a taxable income? And we might go and look at the laws and say, hey, according to the laws, there's really 3 big categories, tiers of income, and we'll call them modest, middle, high. Now I've simplified it a little bit. There's actually about 6 tiers, but we'll go with that. I have a URL in the notes where you can go look up the exact numbers. Yeah, so say we have 3 brackets, 3 income brackets. So we can go ahead and say taxable income, and we'll phrase this as, it's a little bit odd, but I will phrase it as a union type. So number in this range, this interval, or this interval. So, okay, that's step 1. So I gave you, or we did step one. We got step one by talking to an expert, which in this case was a web page about the tax code. Give some examples of that type. Okay, so what are some? By the way, I should do this before we even get to the particular task. Write a function to return the tax. So I'm going to go and we'll move that down. Examples of the data. What are examples of the data? Well, gosh, I need to look up here. So we're already thinking in terms for numbers, 0, 1, many, maybe fractional, maybe negative. And we sort of see that, yeah, let's go ahead and include, I'm going to go and unsplit this window here. So keep this list of the steps of the design recipe, keep them in your head, write them down, know what they are, be aware of how we're following them and how they help us to the solution, since that's what I'll be looking for when I'm grading your code, if nothing else. Okay, examples of the data, and I want to be able to see, I want to see my data definition as I'm doing everything else, and you'll find that's commonly the case. You're working with some data, you need to see the data definition because that informs every other step of this entire thing. Okay, so examples of the data, 0. Yeah, okay, that's a taxable income. And I'll go ahead and take 1, sure. And I guess I should give the interpretation. This is probably an amount in US dollars. But okay. Negative 30, yeah, okay. What are some other good things to try? So 95.25, that's a good value because that's right on the cusp. Is that a modest income or a middle income? 95.25. Okay. It's because of the square bracket, the way I wrote that half interval notation. Okay, so that's part of a modest income. What is an example of a middle income? Well, 95.26. Wait a minute, can we have fractional amounts? Yeah, 95.25.01, certainly. Can we have amounts that are less than a penny? Gosh, I'm going to go off and talk with the tax people again and say, hey, do those numbers come up in calculations and are they important? Often in banking, you do have that. Like when you're calculating interest, then you actually you apply 3.2% of some balance, and you might end up with a fractional part of a penny. And the banks actually keep track of it. They'll only pay you, they'll round to the nearest penny when they actually pay out, but they'll track it totally. So, okay. Maybe our tax person says, no, down to a penny is fine. Side note, if you're ever dealing with a type and you could be using, say, inexact numbers like doubles in Java, or you could say, in Java, I would use a double if I was tracking dollars. Or you can say, hey, I can use an int in Java or a long. Well, how will I do this in Java not using a double? I won't keep track of the amount in dollars. I'll internally represent it as the amount in cents. Okay? So if $1 would actually be 100 cents. And then in Java, I can use an int if I never have a fractional cent and I don't have any issues with round-off errors. So, okay. Back to here. So yeah, I think good values to try. 95, definitely include 95.25. Definitely include something just above 95.25, and we realize that even that might be, yeah, this little penny here. Okay. So, and what else should we try? We should go ahead and try something on the other end, 38,700, and maybe 38,701. Okay. Can I try other things in that region? Yeah, it might be reasonable. I'm happy with this. I have a 0, 1, many, I have a negative, and then I have things that are on the cusp, on each of the cusps. That just sort of makes sense to me for numeric types. These are reasonable examples that are going to make reasonable test cases. When we have to do test cases later, I'm just going to grab these and not do further thinking about what test case should I use. Okay, so that was step 2 of the design recipe. Step 3. Remind me what step 3 is? Yeah, you can go back and look in the notes. That's cool. Right, the template for any function that deals with a taxable income. So I'll call it like func for taxable income. And so now we're starting with a template straight up. This is I haven't done this before. I've always had several examples of functions and gone back and said, what is the template? We're going to just charge right into the template. I don't know what function. We're going to write several functions for taxable incomes, and I don't even know what they are yet. So yeah, but what type will my function take in? If it takes a taxable income in and gives me I don't know. I can't really put a purpose statement down here. Can I go ahead and write a stub function? Yes, I can. So define func. So we have to look up the definition for defining a function. What should we call our parameter here? I'm going to be given a taxable income. It might have more meaning in the future when I might be using it in a particular context. It might be, a particular customer's income. It might be the, I don't know. Here it's just a generic taxable income, so I'll go ahead and call it a taxable income, A-TI, a TI. Okay. And what should we return? I have no idea what type to return here, but can I still go and write more? Yeah. We can go ahead and our taxable incomes were numbers. Oh, how many variants? We're going to write a cond with how many branches? You got it. And just to remember, the syntax for cond looks like this. There's our 3 branches. Close off all our parens. And now we need to ask questions for each branch. So if you give me a taxable income, so you're giving me a real number in one of these 3 ranges, how do I ask, am I in the first range? Oh, well, yeah, compare me to 9525. So that's going to be the first condition I put here. The first question, hey, the taxable income, was this a modest income? 9525. I think less than or equal is what I want. And again, thinking about this prefix notation for racket, I think of picking up that less than or equal and picking it up and moving it over and setting in between the 2 numbers. I'm like, oh yeah, I got that in the right direction. Okay, so that's my first condition. Next condition is, oh, interesting. So the next cutoff was at 38,700. I guess I can see that by looking up here. I don't need to scroll all the way up. Yeah, so here's what I'm going to put as the next condition. And I have to be in that interval, right? So 9525 has to be strictly less than ATI, and ATI less than or equal to 38,700. I like this. I'm happy with this. You might have a shorter way of expressing this. You might take advantage of the fact that, hey, cond goes top to bottom. If we don't fall into this first cond branch, we already know that we're not less than or equal to 9525, so ATI must be greater than 9525. And so we could actually get rid of this. We know if we make it to this branch of the cond, we know that that part is already true, so we could do the short circuiting inside our programmer's head. That's okay, I'm not going to worry about that. I'm going to go ahead and leave it here for 2 reasons. One, the main reason, it's a perfect analog to my data definition, and I want to be really clear. I'm trying to teach how these things match up. I want to be really clear how this code matches up to the data definition. Second of all, I can go ahead, if I write it like this, I can go ahead and move branches around. I can swap the order of my cond branches. And that's just slightly more robust code. I don't mind having cond branches where the order really does depend on, evaluating the third branch, you are relying on the fact that the first 2 branches didn't apply. On the other hand, if I can write code where it doesn't rely on that, and I just say, hey, yeah, here are the cond branches in any order you like, that's just more robust code. So I'll go ahead and do that. You might notice, by the way, how I write this less than sign. I swapped the order here, which is a little bit odd. But I do that because here's what I'm thinking. I'm thinking of something like 95. If I were in a math class, I'd write it like that, and I'd go 9525, and then ATI, and then 38,700 as I read left to right. Those things occur left to right in the same order. I have to repeat the ATI twice because we're not Python. Oh well. Good. Last branch. Again, if you wanted to say else here or hash true, because you know that if we on those first two branches were the last one, but I'm going to go ahead and say last branch is if, what is it, can I go ahead and have some number 38700 API. As I'm writing the template, I'm going to be really clear. Did I get my less thans and less equals correct? I get to scratch my head, maybe look up my data definition. When I did examples of the data, I already became aware of exactly where those dividing points were. So I know that 38700 counts as a moderate income. Okay, so anyway, there we are. That is our template. Okay, we have passed step 3 of the design recipe. Oh my goodness, Barlin, this is taking forever. Everything we wrote we'll need to write every time we write a function for taxable income. So we're going to work through 2 of them really quickly, because I can copy and paste this, we're actually saving time. We're going to recoup on our investment, don't you worry. Okay, so now, yeah, next step, let's go ahead and task is here. Let me get all 4 lines. Okay, so step 4 now we're in the per function stuff. And now I'm going to start giving you functions. One function, write a function that returns the tax due. And here's the brackets that you pay 10% of that first bracket, 15% of the next bracket, 25% in the top bracket. These numbers are all correct. Again, there's a few higher brackets, but this covers like 90% of the US population, just the 3 that I have here. Something like that. Okay, so yeah, what are some, so I'm going to write a function called tax, and yeah, I'm going to go ahead and make some test cases here. So I've already gone ahead and put some of these numbers, grabbed them down, oops, except may have been left over from a previous year and not updated. Yeah. Okay. Last one I just made 10,000 bigger. I'm happy again with these small things here. Okay, I'll even put them in order. Well, no, let me leave them in that order. Okay, so again, you pay 10%. If you're below 95.25, you pay 10%. If you're above 95.25, you pay, well, you pay 10% on that first 95.25. Then you start paying 15% above that. Notice that the tax structure is naturally tiered like that. If it were just sort of like, hey, as soon as you moved into the next bracket, you pay 15% on all your income, that would have this unfortunate side effect, right? If you think about it. That means if you're in this income bracket down here, you're great, I'm paying 10%. Oh gosh, I don't want to make more money because then my taxes will go up on the whole chunk. That would be a bad tax law if it made people not want to earn $1 more because they would end up with less. So the way it works is, yeah, you pay a certain amount on this range, and then if your income is up here, you pay a different amount, but the 15%, but you only pay that on this, how far you are into that next bracket, okay? So, anyway, what's tax due? And we can have some different numbers here. I think we had -30. Okay. Tax due, if you have -$30, it turns out, I didn't mention this, if you have a net loss, you don't pay any taxes. Okay. Tax of 0, well, clearly should be 0. $10, you make $10, you're being taxed 10%, your tax will be $1. Okay. 95.25, that's within that first bracket, so you pay 10%, 10% of 95.25 is 952.5. I can write it as 0.50, it's the same number, right? Okay. Okay. 95.26. Oh, I pay the, here's my thinking. I pay 10% on the first 95.25, so I'm going to be paying this much, and then I'm going to be paying a little bit more, right? I'm going to add something onto it, so I can even write it like this if I want to. How much do I add? Of that extra $1, I'm paying 15% of that. So that's, there we are. Okay, so that's the number. Maybe I just would have done this in my head and write down 952.65. Writing it like this actually makes it a little bit more clear to readers of the code why you got that number. Okay, how about 925 and just 1 penny? Oh, okay, well, plus 952.50, and then 15% of 1 penny. So I'll go ahead and I'm going to say for this problem we are going to keep track of, for the tax, we're going to keep track of the fractional amounts less than a penny. Okay, we're fine. Especially in Racket, I know that we're using exact rationals, so as long as I never take a square root or something, which doesn't happen much in the tax code, I'm going to not have any rounding errors or overflow, underflow, overflow, anything like that. Okay, 38,700, the most I can make in that middle tax bracket. What is it? Well, you pay this much of the lowest bracket, and then everything beyond that. How much is beyond that? How much beyond is beyond your 95.25? I don't know. I'll just write this. Okay, so here we are. Everything beyond this, on this amount, we're going to pay 15%. Okay, so gosh, I'll just go ahead and pay 15% of that amount. And that's how much if I'm at the top end. Okay. What if I made, and so now I did include one more value here when I made my test cases. I want to check something that's into that top bracket. And maybe to make my life easy, I could have chosen $1 into it like we did before. I just chose $10,000 into that top tier. So in this case, how much is it going to be? Well, you have to pay 10% on the first 95.25, pay 15% on that next chunk, and then you still have 10,000 more bucks to pay taxes on. Stupid government taking all our hard-earned money. Yeah, so how much is beyond 38,700? 10,000. I made that life easy, and it's a 25%. Take that, add those all together. That is how much I should be paying. Okay, test cases. A little bit of pain to write out. Good to have, because when I go and run my code, I might get something wrong. A less than or a less equal or anything like that maybe would get wrong. Let's find out. Okay, let's go ahead and write that. So that was step 4, test cases. Step 5, and I agree, steps 4, the parts of step 5 all might occur in a bit of a bundle there. But okay, so go ahead and give the signature, give the purpose statement. We're going to stub it out. How do we stub it out? And we go ahead and get rid of scroll this way down. Great, I'm going to do that much. And then, oh, hey, go up and grab that template we had. Okay, and put it here. Except this won't be called func for taxable, it will be called tax. We decided to call this. Okay. And again, I can go ahead and make my purpose statement actually mention my parameter by name. Okay, so now we're ready to do the step we've been waiting for all this time, is fill in the ... dots. So again, did I get that right? Yeah, we just did steps 4, the test cases, steps 5, the stubbing out, copying that template. And now we're at step 7. Okay, and now we're like, well, what was this? Oh, this was just 10% of, now that I think about it, so 10% of there. Except we have that test case that if we were less than 0, yeah. If I didn't think of that, by the way, so that's actually not going to work. Because I don't want to say, hey, my tax is negative $3. You don't get a tax refund if you have a capital loss or an income loss. So yeah, okay. We go ahead and I'm just going to leave this and have it fail. If you forgot that might be happening, when we fail, the test case would be reminded, and we can come back and fix it then if we want, or I might just for this video here, for purposes of time, saying, yeah, go ahead and fix it, and can probably use max or min to do something like that. Say that the tax has a minimum of 0. So, oh, okay, I said it. Min 0. That. Okay. I'm in this range here. How much do I pay? Oh, yeah, I've worked that all out. I'm going to pay $92.50 plus the amount in excess. In fact, I'm going to copy and paste this expression right here, and I'm going to stick it. Let's be polite. I'm going to stick it right there. Except that it wasn't, for that example, I used just a taxable income. So, okay, I think that will give me the answer there. And I can actually do that down here. If you're over that last amount, yeah, our thinking through that problem was that was where all the work of the coding really happened. We weren't aware of that at the time. But, okay, and so the only amount that this was, actually this was the amount that was, this is the taxable income less the 38,700. Okay. I will say, by the way, there is a shorter way to write this code if you want to go ahead and have a recursive solution, which would not be inappropriate for this problem, but it wouldn't be following the data, and I'm trying to stress that, hey, our code is following the data. So we'll come back and talk about other ways to do this that vary the design recipe. The design recipe is not law. It is a set of, it's a checklist to give you guidance, to get you from a blank screen to working code without having to think too much. Sometimes you might bend the rules for certain reasons. Before you bend the rules, make sure you understand them. So, okay, so before we do a recursive solution or something like that, we'll just go ahead and do this. There we are. Let's go ahead and run it. And I'm not sure if I have all my things. Okay, bad parenthesis. Told me to write it, highlighted the one that was missing, so that definitely helped to track it down. My template way up here, okay. Got all that. Okay, oh, I had done this. Let me just comment out. And I may not have mentioned this. A really cool way, if I want to comment, I could go ahead and put a semicolon in front of every single line. Or I could have put a block comment up at the top and then at the bottom. It turns out there's a really nice thing in Racket. Since everything is parenthesized, an expression, if you see an open paren, you know that it's matching closed paren is where that expression ends. There's a way to comment out just the next one expression. And it's not semicolon. Semicolon is a single line. Hash semicolon. So hash semicolon is going to comment this out, but leave the template there for later. I wrote the template twice is what happened. I guess I can just delete that. But it's good to know. Here's one reason why I like this hash semicolon as a comment character. You can use it in the middle of things pretty well. You can go ahead and just want to comment out one branch. You can do that. Even if you've been writing code and you'd split this across several lines, this would once, at the beginning of that, will comment out this entire, from this open bracket to the matching closed bracket. So, okay. Anyway, let's just compile. I'll comment it out there. I'll make sure the file only has one copy of it. I'll decide which one to keep later. Did I get all this? This was the syntax. This is not meant to be actual code, so let's comment that out. That I'm going to go ahead and comment out like this. Get it through. Okay, 3 of the 24 tests failed. -3 differs from 0, the expected value. I thought we'd put in that code. Oh, okay, well, I got it wrong. I did not mean to get it wrong. Let's go and look at that. We can do that. Next one, actual value 0 differs from 1, the expected value. So 297, 299, and click on that error message and it'll bring us right to it. This one, another thing to note about Dr. Racket, this pink one is the test that failed, okay? So that black stuff up there, that is not actually saying that that is wrong. Black means, this is a code coverage tool that Dr. Racket has. It means that line of code was never, ever, ever run, okay? So that's okay, it was my template, so I didn't want to run it. Okay, so yeah, so this test failed, okay? The -30 failed, I'll come back to that later, but this one definitely should have failed. What gives? I have no idea why. A minimum of, oh yeah, I don't want to take the minimum of 0 and some positive number. I want to take the biggest of those. And what if the tax amount was negative? I'd want to take the maximum of that negative number and 0. So hopefully as I was typing, you were shouting at me through the screen saying, no, 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 that's all wrong. Good thing I have the test cases that I do catch this and can track it down pretty quickly. So if I knew that my input was 10, I'm like, I know what should be going on here. Why? Oh, max of 0 and 1, or min of 0 and 1 really wasn't 1 like I thought it should be. I goofed up. Okay. Run this. All our tests pass. Okay, so that one caused a bug in several places. Okay, cool. Let's go ahead and take a break, and let's come back on the next video and do another example that's illustrates some other interesting things going on with data definitions and union types.